Hello everyone, welcome to my YouTube channel, and at the end of this lesson you will be able to carry out addition and subtraction using one's complement. Thank you. Conversion from binary to one's complement. So let's convert the following from binary to one's complement. Let's convert A. Let's convert 1 1 0 1 1 2, and B. Let's take 1 0 1 1 1 0 1 in base 2. All right, so let's convert these binaries to one's complement. If you want to convert 1 1 0 1 1 from base 2, that is binary, to one's complement, if you want to find one's complement of these, what you simply do is wherever you have 1, you replace it with 0, and wherever you have 0, you replace it with 1. Okay, so wherever you see 1 here, you replace it with 0, and wherever you see 0 here, you replace it with 1. And that's what you're gonna do in each of these questions. Okay, so let's take this particular one. One's complement of 1 1 0 1 1. So let me take the A. The one's complement, let me write here one's complement. So the one's complement of 1 1 0 1 1 is, you have your 1 here, so you have your 0, you have your 1 here, you have your 0, you have your 0 here, you have your 1, you have your 1 here, you have your 0, you have your 1 here, you have your 0. So this is the one's complement of 1 1 0 1 1. So let's take the B. So the one's complement of this is, you have your 1 here, 0, you have your 0 here, 1, you have your 1 here, 0, you have your 1 here, 0, you have your 1 here, 0, you have your 0 here, 1, and you have your 1 here, 0. Okay, so that's how to convert from binaries to one's complement. Okay, so guys, let's carry out this addition using one's complement. So we have positive 5 plus 6, and we are given n. This n here is the number of bits. We are given number of bits to be equals to 5. All right, so the first step in doing this is to convert this positive 5 to binaries, and also to convert this positive 6 also to binaries. Okay, so let's start with positive 5. If you want to convert this number to binaries, so this is the method I normally use. 5 equals to 4 plus 1. Okay, and my 4 in binary is 1 0 0, and you have plus 1. So 1 0 0 plus 1 will give you 1 0 1. Okay, so this is the binary equivalent of 5. Now, since we're given n equals to 5, that means to add 2 more extra bits. So let's add 2 more extra bits. That is 2 zeros. 1 2. Then we have 1 0 1. Okay, now the most significant bit here, this 0, shows the sign. All right, this is the sign bit. That means the 5 here is positive. That's why it is 0. Okay, so this means that the 5 is positive. Okay, that's why it is 0. Now let's consider 6. 6 is equals to 4 plus 2, right? And 4 in binary, you know, your 4 is 1 0 0, and your 2 is 1 0. Okay, so when you add the both, you will have 1 1 0. Okay, so let's add 2 bits, okay, to make it 5, because our n equals to 5. So we have 6 now equals to 0 0 1 1 0. Okay, and this becomes your what, your sign bit, and since it is 0, that means the 6 is what, positive, right? Now the next thing is for us to add these two binary numbers, because we are actually adding positive 5 plus 6. So let's start with the 5. We have 0 0 1 0 1. We have plus, let's add with the 6, 0 0 1 1 0. Okay, So 1 plus 0, we have 1. 0 plus 1, we have 1. 1 plus 1, that is 1 0. We will drop the 0 and carry the 1, right? So that 1 plus this 0 plus this 0, we have 1. Then we have 0 plus 0, then we have our 0. Remember, this 0 is a sign bit. Since it is 0, that means the number is positive, right? The number is plus. So the answer is now 0 1 0 1 1. Okay, so this is the binary equivalent of positive 5 plus 6, and this is equals to 11 in decimal, right? So this is equals to 11, and 11 is positive because we have 0 here. So guys, let's take this other example. Let's carry out this addition, negative 3 plus 7, using 1's complement. Alright, so the first step is to convert 3 to binary. So we have our 3. So I'm going to use this method I normally use. 3 equals to 2 plus 1, and 2 in binary is 1 0 plus 1, and this is 1 1. Now our n here equals to 5. That is the number of bits. So here we have only 2, so let's add 3 more bits. So you have 1 2 3. Okay, so 3 in binary is now 0 0 0 1 1. Okay, so the next step is, notice here we have negative 3, and here this is positive 3. Now for us to have negative 3, we need to convert this positive 3 to 1's complement, right? So we need to convert the whole of this to 1's complement. So the 1's complement of this 0 0 0 1 1 will give us negative 3. So in order to find 1's complement, remember 1 will change to 0 and 0 will change to what? 1, right? So let's do that here. So the 0 here, we have 1 1 1 0 0, right? This now equals to negative 3. This is the 1's complement of this positive 3, which is what? Negative 3. So 1's complement of positive 3 is negative 3. Take note of that. Now let's get to 7. 7 here, you know, the 7 is positive, so we are not going to find the 1's complement. We will only find the binaries, right? So the binary of 7 is, 7 is 4 plus 3. So let's have 4 plus 3, right? So 4 in binary is, you have 1 0 0, and 3 in binary is plus 1 1. Okay, so let's add this. So our 4 plus 3, that is 7, equals to 1 1 1. Here we need to make it to complete the number of bits, that is 5. So we add 2 more bits, 1 2. All right, so we have 0 0 1 1 1. All right, so this is 7 in binaries, right? Now the next thing is for us to add negative 3 and positive 7. So we have our negative 3, 1 1 1 0 0, and we have our plus positive 7, 0 0 1 1 1. Okay, so we are going to add this 0 plus 1 1 0 plus 1 1 plus 1, that is 1 0. You keep your 0 and carry over your 1. You have 1 plus 1 again, that's 1 0. Keep your 0 and carry over your 1. Then you have 1 plus 1 again, that is 0 and carry over what? 1. Right? Now we have 1 0 0 0 1 1. Right? Now if you notice, the number of bits here are 1 2 3 4 5 6. They are now 6, right? So you have an extra bit. You have an extra bit of 1. So whenever you have an extra bit like this using 1's complement, so what you need to do is you bring the extra bit down and add it all over again. So this is the extra bit, you bring it down and add it to what you had here before. Okay, so we are bringing the extra bit down because we have an extra bit. It's now 6 instead of 5, so we bring it down. Now you add it again, so 1 plus 1, you have your 0 and take over your 1, then 1 plus that 1, you have your 0 and carry over 1. So we have 1 plus 0 here, we have 1, then we have 0 and we have 0. Okay, now we have 1 2 3 4 5. We now have 5 bits, and it now correspond to what we were given. Now whenever you have the 5 bit, I told you this is your sign bit showing that it is now positive. So now you have positive, and here 0 1 0 0 is what? 4. So your answer is positive what? 4. So negative 3 plus 7 is positive 4. So let's carry this particular example. We have negative 13 plus 14. Let's do this using 1's complement. Okay, the first step is we need to convert 13 to binaries. Okay, and my method of doing that is by adding two numbers that will give me 13. So I can add 8 plus 5. 8 plus 5 is 13. So that is what I'm going to do now, and the binary equivalent of 8 is 1000, and the binary equivalent of 5 is 101. Okay, if I just add these two, I will have the binary equivalent of 13. So let me just add these two, 1000 plus 101. So I will have 1101. Okay, here we have 1 2 3 4 bits, and our number of bits we were given to be 5. So I need to add one more bit to make it 5. All right, now the next thing is for us to convert 14 to binaries. Okay, but before we convert this 14 to binaries, notice here the 13 is negative, so we need to find 1's complement of this, and 13 to have negative 13. All right, so 1's complement of this 0 1 1 0 1 will give us negative 13. So let's find the 1's complement. Remember, the 1's complement, 1 will replace 0 and 0 will replace what? 1. Okay, so let's find the 1 complement. We have 1 0 0 1 0. Okay, this now equals to negative 13. All right, so now let's come over to 14. So the binary equivalent of 14, let me add two numbers that will give me 14. I will consider 8 because the binary of 8 is just 1000. Then I will consider plus 6. Okay, 8 is 1000 plus 6 in binary is 110. If you want to understand more of this, you have other of my tutorials, and you understand everything concerning decimal to binary conversion at ease. All right, so let's add 1000 to 110. We are going to have 1110. All right, here we have only 4 bits, so we need to add one extra bit to make it 5. All right, so this is our positive 14 and this is our negative 13. The next thing is for us to add the two numbers. All right, so we have negative 13 first, 10010. Then we have positive 14 plus the 14 is this one, 01110. Okay, so let's add this. 0 plus 0, 0, 1 plus 1, 0, carry over 1, 0 again and carry over 1, 0 again and carry over 1, 0, and you have your 1. Okay, this is just basic binary addition. When it's 1 plus 1, you have 1 0, so you keep your 0 and carry over 1. All right, now let's count the number of bits we have. 1 2 3 4 5 6. We have the total of 6 bits, but here you were given our n equals to 5, so that means we have an extra bit, and whenever we have an extra bit, what we need to do is take it down. Okay, take it to down here, right? So you now bring it down, then you add over again. So you have 0 plus 1, you have 1, you have your 0, you have your 0, you have your 0, and what? and 0. Okay, this becomes your sign bit, showing that the number is positive, because when you have 0 as sign bit, it means the number is positive, and you have 0 0 0 1. 0 0 1 is the same thing as 1. Okay, all right guys, let's do this one. This is an interesting question. Let's add these two negative numbers using 1's complement. So we have -7 minus 3. Okay, this is an interesting one, right? So the first step is, let's convert 7 to binary. So I'm going to use this my method. 7 is simply 4 plus 3, and 4 in binary is 1 0 0, and while 3 in binary is just 1 1. So if I add these two, I'm going to have 7 in binaries to be 1 1 1. Okay, but my n equals to 5, that's the number of bits. I'm going to add 2 extra bits here. So 7 is equal to 0 0 1 1 1. Right, now this is binary and this is positive 7. So let's have the -7. Okay, so what we are going to do is to find 1's complement of this positive 7, and we are going to have -7. Remember the 1's complement, 1 equals to 0 and 0 equals to what? 1. All right, so let's find 1's complement of this positive 7 to have -7. Now the 1's complement of this is, you have your 1 1 0 0 0. This now equals to what? -7. All right, so let's do the same with 3. Okay, so 3 in binary, just 2 plus 1, and 2 in binary is just 1 0 plus 1. So 1 0 plus 1 equals to 1 1. This now your binary equivalent of 3, but here we have n equals to 5, so we now have 1 2 3 4 5. So this is positive 3. For us to have -3, we need to find the 1's complement of this positive 3 to have our -3. So this now becomes, the 1's complement of this will be 1 1 1 0 0. This now becomes our what? -3. So we have our -3 and we have our what? -7. So let's add the two negative numbers. All right, so we have 1 1 0 0 0. Okay, and we have 1 1 1 0 0. Okay, let's add these two negative numbers. 0 plus 0, 0 0 plus 0, 0 0 plus 1, 1 1 plus 1. We keep our 0 and carry over 1, and 1 plus 1 plus 1. Okay, we are going to have 1 1. All right, now we have 1 1 0. This is 1 0 0. Okay, so let's count the number of bits we have. 1 2 3 4 5 6. We now have 6 bits. So we have an extra bit here. You know what we normally do? We are going to bring this extra bit down. So we have our 1 here, and we add it all over again. Since we have 1 2 3 4 5 6, we need to bring 1 extra bit down and add it all over again. So here we have 0 plus 1, 1, we have 0, we have 1, we have 0, and we have what? 1. So you have 1 0 1 0 1. This is now 1 2 3 4 5. Now take a look at this sign bit here. It is 1, and I told you when the sign bit is 1, that means the number is negative. So this is equals to -10. -7 minus 3 is -10, and this is equals to -10. That means we are correct. But let me show you how to prove. If you want to prove this, this means 1 0 1 0 1 means this is already in 1's complement. 1 0 1 0 1. It means this binary is already in 1's complement. This number is already in 1's complement. So for us to check, we have to find 1's complement of this. 1's complement of this will give us the binary equivalent of 10. So let's find the 1's complement of this. 1's complement is just changing 1 to 0, 1 to 0, and 0 to 1. Okay, So let's find one complement of this. We have 0, 1, 0, 1, 0. Okay, this is the binary. Now, so this is the ones complement and this is the binary. So 1010 equals to 10. That is 10 in binary, and the 10 is positive. Okay, 1010 equals to 10 and the 10 is positive. Here you see the sign bit here is plus. That means this 10 is positive, and this is the ones complement since it is what? Negative. So your -7 minus 3 is -10, and this validates this particular answer. All right.